Welcome to Ask and Learn.
We are given a differential equation. We are asked to use this equation to graph the slope field and three solutions for the equation. The equation we're given is that y prime is equal to 1/2 y. In order to graph the slope field, let's consider what the slope will be at different points x, y. So, in particular, if we take y to be some constant c in the real numbers, and x is any real number, then we have that slope of y at the point x, c, is going to be 1/2 y, which is equal to 1/2 of c. So in other words, say if c is 0, we have that the slope of y is going to be 0 at every point along the x-axis. So in particular, plugging in different values of c, we have that the slope for any y equal to 0 is going to be 0. So along the x-axis we have horizontal lines indicating a slope of 0. If y is equal to, say, 0.5, we'll have a slope of 0.5. Y is equal to 1, we'll have a slope of 1. Y is equal to 1.5, we'll have a slope of, y is equal to 0.5, we'll have a slope of 0.25. So just barely above horizontal. Y is equal to 1, we'll have a slope of 0.5. Y is equal to 1.5, we'll have a slope of 3/4. Y is equal to 2, we'll have a slope of 1. And you see that the slope simply increases as you go up the y-axis. You can extend each of these from the y-axis for all values of x. A little bit of a rough drawing, but the idea is that as you go further up, away from the origin, that the slopes get steeper and steeper. Likewise, if y is negative, say -1, we'll have a slope of -0.5. So we see that as we get further and further from the origin in the negative direction, our slopes will get steeper and steeper. This is just a very rough slope field that I've drawn here, but I think it conveys the general idea. To find three solutions, let's pick three different initial values. For example, let's take an initial value y of 0 is equal to 0. And we'll have a point. I'll draw this in black. That's 0, 0. And we'll see that this is simply the horizontal line. It's even hard to see because it overlaps with the x-axis. It's just the horizontal line, x equals 0. Another initial condition that we can use is y of 0 is equal to 1. I'll draw this in red. You can see that this is a point at 0, 1, and in order to graph it, we simply follow the slope field as best as we can. You see that this does approach, as x approaches negative infinity, the asymptote of the x-axis, and as x approaches positive infinity, approaches infinity. It looks a little bit like an exponential function. Now, one more initial value we'll take is y of 0 equals negative 1. So now we've got one for above, below, and on the horizontal asymptote. And I'll graph this in green. So we know we have a point 0, negative 1 in the graph. We see that as x approaches negative infinity, this approaches the asymptote y equals 0, and as it approaches infinity, this graph approaches negative infinity. You see that this is another kind of exponential function, except for it's been reflected across the x-axis.